Example 8, we have the integral from -2 to +1 for this rational function. And what's really important again is that we need to recognize that we are integrating across a vertical asymptote. So if we take a look at the denominator, that's going to give us a vertical asymptote at -1. So I've drawn in the vertical asymptote at -1. And we need to split this integral up into two parts, the left part in green and the right part in blue. So again, the first thing is you need to recognize that you're integrating across a vertical asymptote. It's an improper integral, so we need to set this up using limits. So the left-hand area, I'm going to set it up like this, the limit as a approaches -1 from the negative side, because we're approaching in this direction here. And the integral is going to be, the lower bound is -2, the upper bound is going to be a. And we have x plus 1 to the -2/3. And we're going to evaluate that from, oops, I'm not going to evaluate that yet. So that's the left area that we're going to evaluate. We do need a dx though. And then we're going to set up the right area. So plus the limit as a approaches -1. This time we're going to approach that asymptote from this side. So we're going to approach it from the positive side. And our bound, in this case, our lower bound is a, and our upper bound is going to be 1. And it's going to be the exact same antiderivative. Okay, so we set this up using our limits. And what's most important though is that we split it up into two separate integrals. So I'm then going to anti-differentiate this expression. So I get the limit as a approaches -1 from the negative side. Anti-differentiating this, I'm going to end up with x plus 1 to the power of, I add 1 to -2/3, I get positive 1/3 power. I'm going to divide by 1/3, which is same as multiplying by the reciprocal. So there's my antiderivative, and I'm going to evaluate this from the lower bound of -2 to the upper bound of a, which is going to approach 1, plus the limit as a approaches -1 from the positive side this time. I'm going to end up with the exact same antiderivative. But this time my bounds are going to be different. It's going to be the lower bound is a, and the upper bound is going to be 1. Okay, so then I can evaluate these limits. I can plug in my a into these limits. So I'm going to end up with 3 times the cube root of, when I plug in a from the negative side, I'm going to be approaching 0. Actually, maybe I should keep, yeah, let's do that. I'm going to approach 0 from the negative side, minus, when I plug in -2, I'm going to end up with square root -1. Sorry, cube root. These are both cube roots. Okay, and then I'm going to evaluate the right-hand side. It's going to be I'm going to put the limit in. So I'm going to do 3. I'm going to factor that 3 out. I'm going to put 1 into here. So I'm going to end up with the cube root of 1 plus 1 is 2, minus the cube root. I'm going to plug in 0 from the -1 from the positive side. So I'm going to end up with +0. Really, it's just going to be 0 in both cases. Okay, because we're not dividing by that 0, we can just, it doesn't really matter if we're approaching it from the positive or negative side. In fact, maybe we should just erase that because that's not really relevant in this case. Okay, so then I'm going to evaluate this. This becomes 3 times this minus a cube root of -1. Well, that's going to be positive. So the area on the left-hand side is 3 plus the area on the right-hand side is going to be 3 times the cube root of 2. Okay, so the right-hand area is going to be, the left-hand area is 3, and the right-hand area is going to be 3 cube root 2. So we have a finite area here. These are both bounded and finite.